Now, so there's the formula. I've essentially finished here. And notice, what is the magic number? The magic number is the natural log of a. That's what it was. We didn't know what it was in advance. This is what it is. It's the natural log of a. Let me emphasize to you, again, something about what's going on here, which has to do with scale change. So, for example, the derivative with respect to x of 2 to the x is log 2 times 2 to the x. The derivative with respect to x, these are the two most obvious bases that you might want to use, is log 10 times 10 to the x. So one of the things that's natural about the natural logarithm is that even if we insisted that we must use base 2 or that we must use base 10, we still would be stuck with natural logarithms. They come up naturally. They're the ones which are independent of our human constructs of base 2 and base 10. The natural logarithm is the one that comes up without reference. And we'll be mentioning a few other ways in which it's natural later here. OK, so I told you about this first method. Now I want to tell you about a second method here. So the second method is called logarithmic differentiation. Logarithmic differentiation. All right, so how does this work? Well, sometimes you're having trouble differentiating a function, and it's easier to differentiate its logarithm. That may seem peculiar, but actually we'll give several examples where this is clearly the case, that the logarithm is easier to differentiate than the function. Okay? So it could be that this is an easier quantity to understand. So we want to relate it back to the function u. So we have to, so I'm going to write it a slightly different way. So let's write it in terms of primes here. So the basic identity is the chain rule again, and the derivative of the logarithm, well, maybe I'll write it out this way first. So this would be d of log u du times d by dx of u. Okay, these are the two factors. And that's the same thing. So remember what the derivative of the logarithm is. This is, what is it? 1 over u. So here I have a 1 over u, and here I have a du dx. So I'm going to encode this on the next board here, which is the sort of the main formula that you always need to remember, which is that log u prime is equal to u prime over u. Okay, that's the one to remember here. Yeah.
How did you get d ln u over du times du over di?
The question is, how did I get this step here? All right. So this is the chain rule. Okay. The rate of change of u with respect, log u with respect to x is the rate of change of log u with respect to u times the rate of change of u with respect to x. That's the chain rule.